Hello and welcome to the Tuesday, June 25th. This is a special Cluster API session, and we're going to go and do a code walkthrough to Cluster API, some providers, and kind of show also like the development experience. This is like mostly like a free form session, so like we can kind of like be dynamic on like what we want to explore, and kind of adapt like with the audience. So please feel free to write questions in chat, and if you want to like go into more details about something, please let me know or let someone know if I can't see the chat. How does that sound? I linked into the chat the agenda, and feel free to add yourself to the attending list. We're all ready. I'll start sharing my screen. Hopefully everybody can see this. Can someone confirm? How does the font look?
You might want to increase it 1. That's good for me, but if other folks want to speak up.
Good for me too.
Yeah,
perfect.
looks good.
So we are right now working on master, and we're all like up to date with Cluster API master. Some new things that have happened like in the past few days are, for example, that we are like now supporting Go modules, and that we have updated the dependencies, like these two main dependencies, controller runtime controller tools, the V2 version. And the reason we did so was mostly because we want to support multi-version and conversion webhooks. So this is kind of like a required for the V1 Alpha 2 work, which I'm happy to go into more details later if folks are interested. I'll talk about like these two later and like how they kind of like tie up in like all the Cluster API. So for repo structure, like the first thing that you will see is like a README. This is like a pretty generic, and Cluster API as right now, like it's not consumable. So if a user comes to Cluster API and wants to create a cluster, you actually can create a cluster. And that's kind of like a little bit like a backwards. And like when I first joined the project, I had the same experience. It's like, how do I actually create like an AWS cluster or GCP cluster? And to do so, like you actually have to go into a provider implementation and build your tools and everything that you need to create your cluster there. And the experience is kind of different from each provider. So what I'm talking about right now is like mostly V1 Alpha 1. Then like a lot of like these problems, we have like kind of like a scope and objective already like in this doc section that we like kind of like go through like what we want to do with this project. So if you're not familiar with it, like please take a look at this this markdown document. It's under docs and kind of like explains like what we want to do with the project. And definitely 100% familiarize with the glossary. This is pretty important so that like when we speak to each other and we talk like in issues or like during community meetings, like we know like what we're talking about. One definition that like I always like wanna like point out is the workload cluster definition. This is the cluster that we're trying to create, the cluster that a user is trying to create. And you also like hear like about a Bootstrap cluster or Pivot, which we'll go into like soon. So directory structure, top level, we have like some GitHub issue template, which we can skip. The build directory is for some like build Bazel files. The juice of it, like really like it's in the CMD, the command directory, and the package directory. CMD is like very important. Like from a newcomer perspective, you have these 3 folders. One is an example provider. So if you're a developer and you are kind of trying to create your own provider, this is a good starting point. It's not like complete because you will need like a lot of more other things. And you can see it's like kind of like pretty simple, right? Like it says, I want to initialize some things and register. And to be honest, like this is mostly like boilerplate code at this point. But there is like a lot of things right now in here that you would be like, what is this cluster actuator, machine actuator? So historically, we have cluster API was all like done in one repository, and then was split into multiple repos. And right now, for example, like the AWS providers in one repo, GCP, vSphere, etc. The actuator is kind of like an interface, and we'll go and like look at it, which infrastructure providers will fulfill to like kind of implement their own business logic. And this is what was like kind of a decision made early on in the kind of like early on in the project. But I honestly don't like this, and like a lot of people like have like kind of have said like they want to go away the actuator. And the good news is in V1 Alpha 2, we agreed to get rid of the machine actuator. And I believe someone is working on to remove the cluster actuator as well. And this brings a lot of more problems that I'm happy to talk to about. The other two things here is the manager and cluster cuddle. Let's go to manager first. It's like kind of simpler to go into the manager. So this is where Cluster API kind of interacts with controller runtime. Controller runtime is an upstream project to create controllers. Controller tools is another project that helps with the creation of these controllers. So for example, for code generation or like type generation, CRD, etc. So there is like a lot of things going on between controller runtime and control tools. Controller runtime in this case, like in the main.go for the manager, this is the cluster API manager that will run in the pod when you run cluster API. I don't know like how many of you have like run, for example, the AWS provider or any other provider, but alongside an infrastructure provider, you have to run also the cluster API pod. And the reason for that is because cluster API pod is generic, and it will watch specifically machine set machine deployments. So because like those are generic operation that cluster API can do for you. And going forward, we want to move more logic upstream. So in like what will run in this file, like will be more controllers, so that we can make it like some, for example, like if we remove the machine actuator from the providers, we'll be able to. Could you mute if you're not talking, please? So when we remove the cluster actuator, for example, in V1 Alpha 2, we will register another controller in here. And that, like, for example, here we're only registering like this function is actually only registering two controllers, or like three, but one of them is deprecated, which is machine deployment, machine set. And this is to kind of like manage the generic operations. So you can think that like when you are creating an infrastructure provider, a lot of these operations can be generic, but there is like a balanced acting here, right? Like we need to find like good abstractions and then create those abstraction in cluster API, and so that all the controllers will be able to use them. And I'll show you an example later with V1 Alpha 2 and how like that improves a little bit development experience and the user experience as well. Now, the other most debated thing about cluster API is cluster cuddle. How many people here have used cluster cuddle at least once? The funny thing is, when you build cluster cuddle for cluster API, it actually doesn't do anything. It cannot do anything because there is a lot of kind of like, not craft, but like there's like a lot of things that have been deprecated, but they will be removed in V1 Alpha 2. And those things, for example, are in this nice folder, this provider here, this provider.deployer. I don't know how many of you like actually kind of like looked here, but so cluster cuddle, when you build it from an AWS provider perspective, it will kind of like build this binary, which will hook up into the AWS specific deployer, which will fulfill this interface to to return the IP and the kubeconfig for the AWS cluster. So it's very specific and tied up to like how do you manage like API server and like kind of like how do you get the IP of that API server machine or cluster, or how do you generate the kubeconfig. So this is left to the providers, and this is one of the major things that like we kind of fight for every time, because it should be generic, but it isn't, because we don't have enough kind of abstraction to make it generic yet. In here, there is like a bunch of other things that are important. One of like, two of them, like I'll go into, is definitely the phases. This is pretty important to understand like what's actually ClusterCuddle doing when you want to see like each operation. So during, I think, like past year and like early this year, the team worked to kind of to bring ClusterCuddle into a phases approach, so that you can actually like tell ClusterCuddle which action to take, and not just say like create cluster and we'll do a bunch of things. But let's go into ClusterCuddle a little bit. What does it do? ClusterCuddle like comes up, and you can give it a configuration file, and which like the infrastructure provider has to generate for you. And then it will spin up a Bootstrap cluster, which is a temporary cluster to create your workload cluster. And during this time, your controllers, so Cluster API and the infrastructure controller, will run into Bootstrap cluster. After the first node is up, so the control plane is up, then ClusterCuddle will perform the pivot, which here, like you can find as a pivot phase here. And what that does is that it will move all the resources from the Bootstrap cluster to the workload cluster. And so now the workload cluster is actually managing itself. One of the things that we have talked about in this project is the concept of a management cluster. So it's a Kubernetes cluster that you already have and that you want to use to manage other clusters. And ClusterCuddle actually falls short and doesn't actually support that as a first class. But that, like creating clusters in a management cluster is actually pretty easy. So like you might not actually need ClusterCuddle. And so maybe like in the future, and Tim Sinclair is actually working on this, we will definitely revisit like what's ClusterCuddle going to be. Tim, do you want to add anything to that?
There's an umbrella issue where if you have thoughts or feelings, I have strong feelings about ClusterCuddle, not necessarily because they're deep-rooted feelings, but more because just design philosophy of what should be doing what, where, when, why, and how. There's an umbrella issue that kind of enumerates all the things that ClusterCuddle does from a high enough level, and kind of tries to propose ideas around how we could potentially nix ClusterCuddle itself. I'd love feedback, because there's a lot of things from a command line utility where at this layer, it violates some of the core design principles. So if you have thoughts there, please add them to that issue.
Vince, there's a question in chat from Cornelia. Am I understanding correctly that ClusterCuddle assumes the pivot non-system Kubernetes approach with Cluster API, but Cluster API itself does not?
I need to unpack this a little bit. So yes, ClusterCuddle assumes pivot. I'm not sure about the second part of the question.
Yeah, Cluster API does not itself. So like one of the components for that I mentioned to get rid of ClusterCuddle was that on the cluster spec, we should potentially have a potential option on the cluster spec, which would be like pivot to workload cluster, or some parameter that allows you to rectify the deployment of the cluster to so that the objects are on the actual deployment cluster. That currently does not exist. That's baked into ClusterCuddle today. People can deploy clusters in many different ways without using ClusterCuddle. I consider ClusterCuddle to be a convenience tool.
Okay, I get it. I had gotten the sense, I can speak, right?
Yep.
Okay.
Yeah.
I had gotten the sense that just a sense, and you can correct me if I'm wrong, that the cluster API community was leaning more towards the system approach as opposed to the pivot approach. And that's why when I heard you, at first I parsed it like, oh, it requires a pivot. And then that's where I was like, oh, is it cluster cuddle that requires the pivot?
Yes.
Yeah.
That's the shortcoming, right?
TLDR is that there's many deployment scenarios in the community. What we do is we feedback from the wild. So it's most of the things in SIG cluster lifecycle are people tell us what they're doing, and we try to mechanate around the common patterns to distill the common use cases. But there's no way we can encompass all of them. People use tools in fascinating ways.
So is there a common pattern? Is pivot a common pattern, or is system Kubernetes or system cluster more of a common pattern?
They use both. The two, it exists both that I've seen.
Okay, super.
And
thank you.
The Bootstrap scenario, it's very helpful when in the development scenario, if you want to quickly create a cluster and you don't have a Kubernetes cluster running, or to just go from zero to Kubernetes in a much faster way. So yeah, this is definitely up for the discussion, how cluster cuddle will shape in the long term. In this folder, definitely the phases is where kind of a lot of the code happens. And I already pointed out the provider package. This package is the one that's actually kind of not making cluster cuddle work across providers yet. So that's something that will definitely, it's a shortcoming, and we'll definitely need to work towards maybe removing or redesigning this package so it's kind of more generic. And there are things in V1 Alpha 2 that will allow it. Honestly, haven't thought them all of them through yet, but yeah. So moving on, let's. I want to actually switch just before actually moving to package, and this is always in cluster cuddle land, and this is something that I kind of played with a while ago, and this does the same exact thing that cluster cuddle does. It uses only one of the alpha phases in cluster cuddle, but this is using a management cluster. So as you can see, cluster cuddle could be replaced by either good documentation or a bunch of a makefile script in this case. But some of them are still required, if you want to apply add-ons. But this really doesn't. It's not actually required. It's just a nice way to have a retry loop. So that's just wanted to point out that management cluster is not that difficult to support. And this actually uses a kind cluster as a management cluster. So it kind of solves a lot of the things that we have talked about. Any questions on this? All right, I'll switch back to cluster API. So let's go dig deeper a little bit into the package folder. This is where kind of most of the things are happening, if not all of them. Package APIs is kind of where we define our own API types. So as you can see here, you have, this is all a generated code from KubeBuilder. And if you're not familiar with KubeBuilder, I'll do a little example there, how to create a new type in Cluster API. It's going to be pretty simple and straightforward. And here we have the V1 Alpha 1 type. And so we're in package API cluster V1 Alpha 1. We have some common here, but let's ignore that for now. I think it's just some HEPA functions. In here, this is how usually in Kubernetes land, a controller can define its own types and /CRTs, and also how we generate those CRTs. So let's look at the cluster types, and there are a bunch of types here. There's cluster, machine class, and machine deployment, machine sets. So these are all the types that go under cluster.k-io, which is kind of our API group that we're using right now. This is the cluster type. As you see, we use KubeBuilder to generate and this is just KubeBuilder markers. So controller tools has some generation.
Can you hold on just 1 second? Like you got to pause a little bit in between that so we can open issues. Ashish or Daniel, can one of you open an issue to change the API group to k8s-sigs.io?
I think others kind is using sigs.k8s.io. So
we should to open up an issue to figure out what group we should be using, but that group is for Bowdoin.
Thank you. So you will see like a lot of these kind of comments. They're kind of scary at first, I have to say, because kind of like what is actually going on here. But truthfully, this is all like actually generated files. So these files like will be generated for you if you're creating a new type, and you'll actually be able to kind of add like new things if you want, and with these tags, and then I'll show you later like how controller tools come into place when we want to generate the actual CRDs that we will apply to the cluster. The cluster here is so I'm not sure like how all of you are familiar with like cluster API types. The cluster is kind of like the definition of like what like kind of the cluster looks like. So it's the name of the cluster. We'll have like some network ranges for services and pods. This actually was made optional not long ago. So like, this is actually not needed because it's left actually to the provider, infrastructure providers, to decide which network ranges to put. And this is just like a convenience place to kind of have the CIDR blocks specified. One thing that I wanted to mention, in Kubernetes, you can have CRDs with sub-resources, and one of them can be status. I think the only one right now is actually status that's supported. And the status is a special kind of resource.
The other one is scale.
Oh, scale, yes. That's actually used in machine set, I believe. Thank you. Status is kind of a special resource, and the reason for that is because users should never set status. So like from kubectl, like you would never like kind of see a user kind of setting the status for a resource. And controllers should use status to kind of like store some information, but status should be you should always be able to recreate the status from your spec. So if you lose status, and like, for example, like if you back up your cluster and you recreate all like you just like restore a backup, for example, your status is going to go away. So you don't want to actually store things in status that are not recreatable. And so a lot of controllers actually like will use spec for either like fill in defaults. So for example, the cluster API provider AWS uses the cluster spec, not this one, but the cluster provider spec. So its own spec to actually store the certificates, but it won't store those in status because we might lose them and we might never be able to access the cluster. The machine types is actually the type that's going to change for V1 Alpha 2, and the proposal has been merged, and all proposals are like under docs /proposals, so like you will find it here. And there's like a lot of details there, like what's going to change in the machine spec. So all of these things that you're seeing today are for V1 Alpha 1. And let's see, like, why do we want to change the machine type? So one of the things that we see here, like we see that we have machine spec and machine status, and that's kind of like follows the same pattern as before and any other kind of Kubernetes object. In the machine spec, we have object meta, which we say here we will auto-populate the node created. And we don't. This actually, I haven't seen any provider using this. And as far as I know, this will probably be gone in V1 Alpha 2. And one other thing that we found out, like, well, like we upgraded controller runtimes and tools to V1 Alpha 2, is that this object meta was actually using the object meta from the Meta V1 package. And a lot of these in the Meta V1 package, I'll show you like what it looks like. There's like a lot of fields in here, but a lot of them are read-only. And the new controller runtime and tools is actually generating validation for these, and we were failing. And talking upstream, like we kind of found out like we shouldn't be actually using this particular type as like an embedded like type in another objects, because a lot of these things are kind of like either are here for historical reasons or are set from the API server perspective. So we don't want to expose these to the users. But we were doing this, and where was I here? We were doing this, and that was one of like a really fun problem to solve. One of the things that I want to talk about is provider spec. Let's look at this. So as I mentioned, like infrastructure providers are separated from Cluster API. And one way that historically we kind of like decided that how do we allow infrastructure providers to add information to the provider spec to the machine spec in Cluster API? Because we want to reuse the same machine, and we're going to use the same machine, but we want to give providers like the to kind of store their own information on a machine. So for example, for AWS, you will find things like the subnet ID or like the security groups. So very specific to the actual provider implementation. And truthfully, like we went for runtime raw extension. Now, if you look at raw extension, it's actually just an array of bytes. So one thing that like probably a lot of people like analyze is like what happens with validation? Well, the truth is like there's no validation. So when a user like kind of misspells something in the provider spec, and we can see here. So like this would be something like this. There would be a kind and other things. So if I say subnet, and then I don't know, for some reason I add an X at the end, but that's not like the actual subnet ID. There would be nothing telling the user right now that this field is actually non-existent. Or like if I say like I want to add, I don't know, like I know that like subnet ID is correct, but that's a string, and I add S1, nothing will tell the user that like this is actually wrong. So it's like a really bad experience, and there's a lot of trial and error. And I think like most of us like kind of we kind of went through this a lot. And this is one of the problems that we're trying to solve in V1 Alpha 2, which is using CRDs and references to kind of make sure that like we actually do offer validation and give the user a good experience when creating. So let's see. So this was just an example. And so this is what's wrong with provider spec. And provider spec, it goes alongside like the cluster actuator, which I'll show you like a little bit like soon, like how that plays into all of this. So because we have infrastructure provider kind of configuration in provider spec embedded as like bytes, the actuator has kind of generalized some of the logic, but it can't generalize all. So what happens all the time in the AWS infrastructure provider, for example, is that every time we see a machine and we have to reconcile that machine, we actually have to do a lot of encoding, decoding, because that's not done for us. So we will have to like kind of go and use the YAML marshaller and unmarshaller to kind of like deal with this raw bytes. Other things that I want to point out, I think machine version info. This was another thing that like was very confusing at first when I joined the project. So here you can see like there's a machine version info, there's a kubelet, and there's control plane. So I had someone ask me, it's like, would there ever be a case that the control plane version will be different than the kubelet version? And can I specify just one? And if I specify control plane, like would the kubelet work? The answer is yes, but a lot of things are actually deprecated. So there is like, let's look for it, control plane members. Maybe not. Control plane machines. There you go. So there is like a lot of functions in like kind of like utility functions to extract control plane machines, for example. And you can see here in the util package. And this function, for example, just does this. So there's no validation again, like on the control plane. Like, is this actually like, why would I need to specify a version on it? I could specify just, yes, it's a control plane, and like nothing will actually tell me that like it's not working. So to overcome this limitation, for example, in V1 Alpha 2, we don't have the concept of like specifying the version for a control plane, but instead the whole version became a string and it's optional. So some providers might use this information to kind of create their own version and or like use this version to like, for example, get images or like make different decisions, maybe like with a different Kubernetes version. And we kind of generalize like when a machine is going to be a control plane with just setting a label. We already do this for cluster. So the relationship between machine and cluster, it's not explicit. As you can see, there is nothing here that actually specify like a link to a cluster. And we just use labels, and we just say, and I think it's here. So this labels, you just have to set this label to say this machine is part of this cluster. And that's actually like how the machine actually links to the cluster. And there is some parts of the code that actually will check for this. And I'll go there in a second.
That loose decoupling is very Kubernetes. That's the way a lot of things work in Kubernetes.
And I wanted to add, like, the nice thing about using labels is that you can actually filter on it. On fields, like it's not easy to or like, well, there is some ways to filter on fields, but labels are indexed by default. And I could just say, like, if I want to list all the machines in a cluster, it's much easier to do that on a label. Any questions so far?
Yes. Hello. My name is Peach, and there has been a big question ever since I started looking into this project, which is around the raw extension stuff. And I know you mentioned it, but I want to go back at it if possible.
Sure.
Yeah, so you mentioned that there is no validation. I would assume so, at least if you're running the cluster API as it is here in this repo as the thing that is validating the input. But my understanding from some provider code is that they are indeed registering types and doing their own validations. Is this assessment incorrect?
No, that's actually correct. The validation happens in runtime. So when I'm in my terminal, let's say, and I do kubectl apply cluster, for example, I like the simplified version. When I click enter and this goes and creates my cluster or machine, for example, this provider spec won't be validated as part of this call. So from a user perspective, I'm not receiving any signal that my machine or cluster wasn't actually matching the spec. The only way that I can actually check is to look at the logs of the controller.
So the typical vernacular that people use is admission. There's usually type validation on admission control. Yeah. So if you're used to Kubernetes, all the resource objects actually do type validation on admission control. So if you incorrectly format something, if you have a problem with you put garbage data inside your type information, it would spew out and rejected admission. You can't do that currently with this structure.
Even if you wrap a cluster API in a cluster API implementation and put the webhook there?
Could you repeat that?
I mean, so from my experience with implementing the operator pattern, so basically like extending the API and then implementing controllers around that, it's pretty possible. There's nothing blocking you from deploying your own webhooks to do any sorts of validations. So my question here is, as an implementation of Cluster API, can I not enforce that if I deploy my own webhook?
You could, if you deployed your own webhook for type validation. The question is, it gets weird because the main project is agnostic to provider specifics, and if a person wants to, their deployment would be opinionated. Then,
Yes, no,
right?
no, for sure. Okay. But I think that in the end, that's, and please clarify me, that's the end goal of this project, right? To be agnostic enough so that the implementations actually take care of these details.
Yep.
No? Okay. Cool.
Yeah.
Thank you very much.
I also have a question. My name is Shan, and the question is, if you look at this page, the taint object itself is outside the provider spec. But then, for example, if I want to add a node label, I will have to modify inside of the provider spec. So it's not clear to me how the structure was originally designed so that it's, like I would imagine taint and label are all both like Kubernetes properties that should go pretty much in the same place.
You mind if I take this one, Vince?
Sure, go ahead.
So the taints field that's on the screen right now is not anything that is guaranteed to be supported and implemented across every single provider that exists today. They may honor it and do something with it, or they may not. The approach that we are looking to move towards is hopefully removing taints for now from V1 Alpha 2, and instead relying on the Bootstrap configuration to handle initial node labels and initial node taints. So rather than sticking it in the machine spec where maybe it gets handled, maybe it doesn't, if you happen to be using the kubeadm-based bootstrapper that we're going to be developing, kubeadm has native direct support for setting taints and labels when the node is registered, and that'll be the way in V1 Alpha 2 to get those set.
All right, thanks.
And I think maybe this is like a good one for an issue, Tim. So or whoever is opening issues, because like this is like one of the projects, like the problems that we see in Cluster API, right? Like we have these fields and they're optional, and they might or might not be like satisfied by some infrastructure provider. So what that tells me, and I'm like I want to hear like from others as well, is like the experience is not the same. It's not going to be the same from a, like if I want to run GCP cluster or AWS cluster, it's going to be different. And so my expectation will have to change from infrastructure provider to infrastructure provider. And I think like one of the goals is like, as others have mentioned, is like to make these generic enough and actually make them work everywhere, not just one provider.
I've got a comment on that. I think that, I mean, I agree with that goal, but it also may be the case that providers want to be opinionated in certain ways, right? To limit, to limit the different options that an end user can use, and I don't think we want to prevent providers from being able to impose certain opinions. But I think it's something that maybe we can figure out how do we satisfy both goals. Can we bubble up something to the user saying, okay, you've submitted this option, but this particular provider won't act on it or will impose its own option, something like that.
Yeah, to be decided like what that's going to look like, but there's going to be a lot of improvements in V1 Alpha 2 towards that direction for sure. So if that's okay, like I'd like to move on. Like we have kind of 20 minutes left, more or less. So cool. So we talked about types, and as I mentioned, like their package API cluster V1 Alpha 1, And there's going to be another folder here that's going to be called V1 Alpha 2 soon. So look out for that, like when that's going to break all master and everything. But let's see the controllers. The controllers, like where like kind of all the magic happens. And we talked about the actuator, the machine controller. So let's go look around that like a little bit more. The machine controller, and let's actually look at the actuator interface. So you can see like this is what we would expect the infrastructure provider to fulfill to create a machine. So we will like have a context, a cluster, a machine. And when we call it create, like we would expect like the infrastructure provider to actually create that machine and give some information back. This is all like a boilerplate code. So this is something that like KubeBuilder will generate for us. So we'll run the controller, and this is where one of the most important pieces. And you will find this in every other underscore controller, like even the node controller. Actually, no, this one is deprecated. Machine set controller, deployment controller, like this all looks the same. And the biggest, like, and most important part is actually what happens in this reconcile method. In here, what we do is like we fetch a machine. So like we'll have a request, the request comes in, and this it's watching events. And we actually have a watcher, which is here. So we're just watching changes from machine. You can add more watches if you want to, and there is like machine deployment, I believe, like watches multiple objects. So in this case, we're saying I want to watch machines and queue a request for the object when an event happens on that machine. So when you do kubectl create or like update some like a field on a machine, that's where the machine will be fed to, right? Like, and this is going to be one of the controllers. There could be multiple controllers watching for the same object, and so multiple reconcile will be kicked off at that point. So we go and fetch the machine, and we make sure that the machine exists, because sometimes it does happen, the reconcile happens, and in the meantime, like somebody deleted that machine. So we want to make sure that like the machine exists and retrieve all of the information from that machine. The first thing we do is actually get the cluster from that machine. And this is where, like I mentioned the label before, this is where we actually go look at that label and then try to get the cluster. As you can see though, like here we return double nil, which means like if there is no label, we actually we might make the cluster optional. There is some implementation out there that actually don't use the cluster object and just use machines. And they have other ways to tie it all them up to a cluster. This is not like the best thing ever to have this behavior, because what that means is that like the cluster then up here could be nil. And then we have to check if the cluster is nil everywhere. As you can see here as well. But then what we do, and this is where the actuator comes in, is that when we call the create here, we pass in create context cluster and machine, but the cluster might be nil. And this has like kind of caused some issues sometimes, because if you miss the label and the cluster is nil and the actuator is not actually checking if that cluster is nil, it could panic at runtime, right? So like this is probably one of the other shortcomings that I can see about this current code base. So let's go in the logic a little bit, and this is all going to change actually for the machine controller. But you can see here, this is like how do we kind of tie everything up together. So we kind of go into this reconcile. We get the cluster. We set the owner references. Excuse me. If the cluster is there, we set some finalizers. The finalizers are needed for when we do garbage collection, or when a delete request comes in, the garbage collector will remove the machine right away if there is no finalizer on it. So we add the finalizer to actually call the actuator delete first, and then we'll let the garbage collector do its thing. So all of this logic is generic, and we'll actually do and make some calls to the actuator. So you can see here, where I was talking about the actuator delete call. We do delete, and then we remove the finalizer at the end. One other thing important to talk about is Node-REF. One of the things that we have talked about is that a machine will become a Kubernetes node in any case. And the machine status actually has a Node-REF, which is a references to a node that might or might not live in the same cluster. And this was a problem for a while in the project. That's why I mentioned there was no first-class support for management clusters, and this was another place where the management cluster was causing issues. The Node-REF is important to know, for example, the status of a node, the Kubernetes node. And what we do is that we set the node reference on the machine so that we can actually go and query the health of the machine. In the machine set, we can actually say that the node is ready, and so the machine is ready. And when we actually delete the machine, we actually can go and delete the node as well. So there's a lot of things like tying everything up together, and when the machine becomes a Kubernetes node. Any questions so far? Cool. So this is more like the machine controller. I will super quickly create a new, use KubeBuilder to create a new controller, and this is going to be of kind test, but let's ignore that for now. So what I'm doing here, I have KubeBuilder installed locally. I want to create a new controller. I don't want an example. I will put in the group cluster. I want the controller to be named test, and I don't want to create a type. So this is why I specify resource equals false. And I can say version v1 alpha 2. These are useless because I don't want the resource. And KubeBuilder runs make afterwards, but I don't want it to run make, so I just set false in this case. If I run this, I can see that KubeBuilder is actually creating these files. And let's wait a second until it finishes, whatever it's doing. All right, it's done. So this was like a super quick way to create a controller, which is called task controller in this case. And you can see here, like it created these 3 files and this other file up here. This file will add the controller to this array, which it's actually defined in here. And this is called from the manager main.go that we saw before. So this is how kind of everything ties up together in the main manager, in the main.go. So when we run the manager, we actually also registering and running all of these controllers. This controller actually won't work if I run it right now, but there's like a big warning here. It's like you need to do something around for the business logic. And it actually won't do much. So as you can see, it will try to fetch a test instance. That's because we call it test. So this is kind of just how the scaffolding works. You can see the KubeBuilder tags for again, that kind of give, in this case, it's RBAC. And this was just a super quick way to create a controller. And I actually did the same for the Node-REF controller, which sets the node references for the cluster. But it's called Node-REF controller, but actually it watches machines. So it's not watching any Node-REF type. So you can actually change these controllers as you please. And as you create a new controller, it's you will add your business logic in there. Delete these. All right, for developers out there that want to contribute, please contribute to Cluster API. The makefile is a good starting point. I mentioned before that we use controller tools a lot to generate files and CRDs, etc. So we actually do vendor everything in, but as you can see here, I have all the CRD under the config. So this config is built in here, but we actually build it and vendor it because, or like we push it to Git because infrastructure providers will use this specific folder to create their own CRD as well. For example, the AWS provider today like creates a file that's called provider components, which is like a big, massive YAML file, which has all the CRDs from Cluster API and its own. So this CRDs are actually created from controller tools. So quick example, I deleted those CRDs, and I can run make generate manifests here. As you can see, I'm running go run from the controller gen, which is a part of controller tools, and I want to generate CRDs, RBAC, and output everything in here. And the files got recreated, as you can see in here. Oh, this is boring stuff, but this is more or less what Cluster API is today. Anything else you would like to go into in more details?
Vince, how about going back to manager main and just walking through in a bit more detail how the controllers are registered. So going from the line that you have highlighted, 73, into the init funcs that set up all the controllers, and then down to where things are added, like actuator-wise, at least for the cluster one, and then for the machine controller changes that you've done recently, what that looks like too.
Sure. So in here, so we create like the manager first here, and this is just something that like comes from the controller runtime. Then to the manager, we need to add the controllers, right? And we'll also have to set up the scheme, which is the types that we're actually going to use. And this controller add to manager. So if we go here, this is the file that I was showing before. So it's under here, this file. And add to manager will do a range over add to manager functions, which are the functions generated from controller tools, or kube builders. And as you can see here, like we're actually pretty much just adding to the same array with init functions. So this will run when you actually import the package. We add machine deploy, machine set, node ref, and they're all going to end up here. So when we, in the main file, we run this array, the slice will actually be already populated with all those functions. Let's go look at one of those functions, just as an example. So let's get the machine deployment. There's this add function. So this function will create a new reconciler, which we have here, and this is more complicated, but it's like another function which I can go in more details what it does. But the idea is that like all of these things are defined in their own packages, so we have to bring them up to the manager. And so that's like how kind of the chain works. Is the manager calls add to manager functions, which has all the controllers add functions, which are here, which will then kind of like add the manager to that reconciler. And then the manager starts, so if we go back to the main, and the manager starts, all the controllers will actually also like start running, and will receive events, and everything will kind of work as expected. Is that what you were looking for, Andy?
Yeah, thanks, Vince.
Hey, Vince. Yeah, 2 questions here. I can see there that when you're instantiating the manager, you set the namespace. Does this mean that everything in the Cluster API is namespace scope, or is this specifically for something like creating a lock object for high availability for the managers, controllers, whatever you want to call them? Or both?
Yeah. So yes, so pretty much all the objects in Cluster API, all the CRDs are namespaced. So machine, cluster, machine deploy, machine set, and all of them are actually namespaced. So you need to create them in a namespace. This one is actually a flag to watch only a single namespace. And this was added for kind of like a security reason, more than anything. So imagine that like you're running in a management cluster and you have multiple namespaces, and each namespace is, for example, an environment, right? Production, staging, and development, for example. You might decide that like you don't want to run like the same Cluster API across all namespaces, which is the default. So by default, Cluster API will watch all namespaces and all the objects that like are running in all the namespaces. But if you want to like kind of say, I actually just want to watch this namespace, you can actually do so and limit the what the manager will look at.
Yeah, that definitely makes sense. I mean, I've seen a lot of people in the operator community complaining about this exact problem, where you have an operator or a controller that observes the entire cluster, and they just wanted to observe a certain namespace. It's an interesting discussion, but yeah, thank you for clarifying that.
Of course. Any other questions?
We're at 2 minutes, so you might want to wrap up.
Hey, I actually have one. I'm sorry. I always do this in the end of meetings. I can see that I was looking into like how you build code and how you run certain things. And it doesn't seem that the Go calls rely on the vendor directory. Why is there the vendor directory? I want to understand this because sometimes we may run into bugs and we think that we're using the code in vendor and we're not. Unless we're using the flag, I believe is -mod equal vendor in Go.
So which one are you referring to?
If you
said like
if you look to Makefile, yeah. I mean, even the build stuff, it's just Go build.
Like these ones?
Yeah, for instance, there is no -mod equal vendor, so it's not actually enforcing for the vendor folder to be used. Is this something you're aware of? I mean, I've run into this before. I was not able to figure it out if you have anything protecting us from running into that here. Yeah,
so like the vendor folder was left there, and we actually have ways to check that Go mod vendor was actually run before, for example, like you open up PR. And the reason for that is like, first, it's consistency with like what upstream Kubernetes and controller runtime, controller tools are doing. So they're doing the same to keep backward compatible behavior. For example, if you're not on Go 112, just as an example. These, though, like this do use the vendor directory, and that's because, and we do keep it because Code Generator and I believe also Informer-Gen and like pretty much everything in Code Generator doesn't actually support vendor yet, not vendor, modules yet. And so for that reason, we actually do set in CI, the mod equal vendor, and I have to remember where it is. It's over here. Actually, no, maybe it's in the PR that's open for V1 Alpha 2. But the Go path is set in CI, so that's why it's working.
Okay, makes sense. Thanks.
Mm-hmm.
All right, we're at time. Want to wrap it up?
Yep, I think we can stop sharing. Perfect. Well, if there are any other questions, please do kind of come on Slack or open a GitHub issues. And definitely thank you for coming. And if you want to do this, like again, like maybe next month, we'll probably be able to schedule something. Maybe we can talk about V1 Alpha 2.
Let's talk the name. If it's cluster cuddle or cluster control, I'd like to have that debate. Just kidding.
I want to put it to the ground. So
Thank you very much, everybody. This was valuable. Thank you.
take care.
Right.
Bye.